Hello friends, good day. Welcome to our YouTube channel GKR Soft. In this video, we are going to discuss about DTC overview. In our previous video, we already discussed about complete DEM overview, how to handle the events, how to handle the storage condition and DEM enable condition, all these things. But in this video, we are going to deeply discuss about how exactly DTC works and how DTC helps the engineers who all are in the garage. So first we have to understand about DEM. So if you will see this picture, DEM is mainly used to handle the events, meaning it store the events. Events is equal to fault. So whenever the software component is going to report the event, this will get stored inside the DEM, and DEM will be associated with the DCM and NVM, mainly for NVM storage purpose. But in this video, we are going to discuss about how diagnostic trouble code works and how this can easily relate with the DEM. These all are the things we are going to discuss in this video. First, we can start with what is DTC. DTC is Diagnostic Trouble Code. What is the main purpose of DTC? Mainly, it's used to diagnose malfunctions in a vehicle or heavy equipment. The reason is, whenever there is a fault inside the vehicle, when you are taking your vehicle inside to garage, then how the garage engineer find out what kind of fault is this? That's by using DTC. And DTC is usually a combination of alphanumeric characters that correspond to specific diagnostic event and can be stored by the DEM for later analysis. So whenever you are going to do the configuration for DEM event, you have to deal with DTC. But in some of the cases, might be you feel that we will not configure the DTC, but we'll configure only the DEM events. So in that case, you can calibrate the DTC. So all these things it's possible. But whenever you want to identify the fault, you can easily identify by using the DTC numbers. And one more thing is, inside the car or inside the vehicle, if you will see whenever there is a fault, then you will see the MIL lamp. MIL means malfunction indicator lamp. That's also called as check engine light. That helps drivers to understand about what all are the faults it has occurred, whether it is a critical or non-critical. Then based on that, the particular driver can take a decision. So that is a purpose of DTC. What is the working principle of DTC? How DTC works? You can imagine a situation inside your vehicle. Whenever there is a sensor or actuator detects a problem, you can consider in a way sensor actually it reaches the above the threshold value or some malfunction is happening. Then it will immediately send the signal to ECU, which then log the diagnostic trouble code. Meaning, whenever the signal is sent, then automatically the particular diagnostic logic, that means diagnostic trouble code, will get stored inside the memory. So here DEM need the support of NVM. So this can be read later when you are taking the vehicle to the garage. They can read it by using diagnostic tool. Then they will come to know that what kind of fault is this and how they have to solve it. But these all are will be used by DTC. And DTC can be like something related with the manufacturer specific, something relevant with the supplier specific. These all are also is possible. And the ECU may also store other data. Other data means it can store freeze frame data or live data. It will be helpful to understand about your fault. For an example, whenever there is a failure, you need additional of like engine speed or the mileage. So these are the data will helpful to the garage guy to take a further step or to provide the solution. So this also possible, and this also will be stored with DTC. DTC variants. DTC variants means what kind of DTCs we can use. For an example, we can use a UDS DTC, OBD DTCs or J1939 DTCs. OBD2 means it's best for light and medium duty vehicles. J139 it's best for heavy duty vehicles and heavy equipment. For an example, you are working in a company and you are always dealing with like OBD2 relevant DTCs, meaning then you are working for a light and medium duty vehicles. Types of DTC. Basically, we can consider in a way critical code and non-critical code. Code here is diagnostic trouble code. So critical code means already you know that we have to take a decision immediately or this will make a severe damage to the vehicle. Example is high engine temperature or low coolant levels. So these all are you can consider as a critical DTCs. Non-critical DTCs, no need of urgent solution, may something relevant to the emission, but still we have to take a proper attention to solve that particular problem. So these all are generally called as a non-critical DTCs. That's generally example is emission related DTC. what kind of DTC format? So here I have taken example of 2 byte DTC format. For an example, the number is 9234. So this is the way it will be represented in a bits. But this is P1, 2, 3, 4. This is generally called as a manufacturer controlled body code. So this is generally called as a SAE codes. That's we can see it in a upcoming slides. It's an example for 3 byte DTC format. It's a high byte, middle byte and low byte. So if you will see 923400, this is I have represented in a way of bits. Here it's a manufacturer specific code. It's generally called as a SAE code. DTC types. So whenever you are seeing a DTC, so you want to understand, right? You have to interpret the DTC. For that, we have to understand the DTC types. So basically, majorly we'll have a P code, C code, B code, and U code. P means powertrain code, C means chassis, B means body, U means universal network. So whenever you are dealing with a DTC, so whenever customer delivers some DTC relevant details, then by seeing this DTC types, you can understand what kind of DTC is this. If it starts with P, then it's a powertrain. If it starts with C, chassis. B means body. U means universal network. Here I have given one example. Whenever you are seeing 5-digit code B0782, then in the case of B means powertrain. 0 means it's called as a generic DTC. 7 means it's a transmission. 82, here I have just taken example of shift malfunction, but you can understand based on your requirement. How the DTC structure, because most of the cases whenever you are doing a development, might be you have seen that 3 byte DTC, right? So what is the meaning of these 3 bytes? Because whenever customer is giving some number, we are just using for our configuration and we used to configure it. Whenever there is a problem occurs, we used to say that, hey, this is a number. But what is the meaning of the DTC structure? It can generally has a 3 bytes. Okay, so byte 1, byte 2, byte 3. So if you will see here, this is a fault type and byte 1, byte 2 has the different meanings. I have mentioned it here. In the last 2 bits, that means the 7th and 8th, it has the character of SAE code. So as we have seen now, P, C, B, U. And the second character of SAE code is 0, 1, 2, 3. And the third character of SAE code. And this is a 4th character. And now we will see about it. What is the meaning of each bytes? For an example, DTC, actually whenever it's coming to the requirement, it has a 3 bytes, but whenever we are going to see with the status byte, then it will generally has a 4 bytes. So meaning 3 bytes to identify and denote the current status of the DTC. 4th byte is actually about the status. So the byte 1 and byte 2, it is used to identify the component that has failed, and in that byte 1 and byte 2, upper 2 bits helps to identify that it's whether P code or C or B or U. This is the meaning of all these things. And byte 3, it's a failure type byte. It used to identify the failure mode of the ECU. So if you will see byte 1, byte 2 and byte 3. So if you will see the byte 1 and byte 2, it's identify the component that has failed. So in the upper bits, it has to understand, then you will understand about what kind of code is this. Whether P or C or B or U. Byte 3 is for failure type. Then what is byte 4? So byte 4 has to say about the status. So status generally might be you all have seen during your experience, or if you are an entry level engineer, so this understanding is very important. So in the byte 4, we have a meaning for every bit. Bit 0, then in the case of it's called as a test failed. So test failed at the time of request. So the default value is 0. Bit 1 is test failed this operation cycle, meaning current operation cycle. Bit 2 is pending DTC. DTC failed on the current or previous operation cycle. Then in that case, you will see the pending DTC. So if it is enabled, then you will see the 1 bit. If it is not enabled, or that means true means 1, false means 0. Bit 3 is a confirmed DTC. So DTC is confirmed at the time of the request. Bit 4 is test not completed since last clear. That means DTC test not completed since the last code clear. Bit 5 is test failed since last clear. Meaning is DTC test failed at least once since last code failure. So if you will see the bit 4, the default value itself 1. So this is, you have to note it carefully. And bit 6 is also has a default value 1. The meaning is test not completed this operation cycle. So DTC test not completed this operation cycle. Bit 7 is warning indicator requested. So server is requesting warning indicator to be active. So if you will see the default value, bit 4 and bit 6 as the default value. So this is 8421 code. So this is only for representing to more clear understanding, I have mentioned the hex value. So this is the status bits. By seeing the status bit, you can easily say that what kind of the status of your DTC, whether it is confirmed DTC or pending, or whether the test failed or not. All this information you will come to know from this status bits. Now, for clear or more detailed understanding, what exactly every bit it will do. For an example, the bit 0 and bit 1 and bit 6. This will update it immediately because it's a synchronous. So whenever the fault test is completed, meaning your debounce counter reaches the threshold. Debounce counter means already we have discussed in DEM overview. I have mentioned all my DEM videos in the description. You can watch it. It can be a monitor internal, or it can be a counter based, or it can be a timer based. So you already know that what is the meaning of all these bits. And other bits, 2, 3, 7, other bits will be updated asynchronously in the next 10ms cycle, meaning DEM operation cycle. And if you will see the bit 4, the test not completed since last clear, and bit 6, test not completed this operation cycle, are active as 1 at default. So in the initialization phase, you will always see the 50. So if you will see the status byte, whenever you are going to read it, if you will see the 50, then you will come to know that bit 4 and bit 6 default value is 1. That is the reason you are getting 50 at a initialization. So the UDS status byte will be initialized to 50 and all even memory will be cleared with a positive response whenever you are going to use the service of 14. The service of 14 is a DCM service that is majorly used to clear all the DTC. And bit 2, it's a pending DTC, is keep active at least 2 operation cycle. This is you have to carefully note it, because whenever you are going to read the status or whenever you are going for the interview, might be interviewer asked, but you will think about it pending DTC in a different way. But pending DTCs keep active at least 2 operation cycle. It can be cleared at the 3rd cycle if the 2nd cycle report is passed completely. Bit 3 is confirmed DTC. It's cleared with the aging process. If you want to understand the aging process, I am planning to take separate video for aging. There you will come to know about more clarity about aging. This is a possible DTC status combination, very rare, not rare. It's commonly used status combinations. If we will see 50, then test not performed in the initialization phase. If the test is passed, everything is cleared, maybe in the during 14 service, then you will get 0. Whenever there is a test fail, and then whenever the test not performed, different cases, different activities. So this will be more used for you because very commonly used DTC status combinations here. Then what is the meaning of every bits? So already we discussed, but this is more clarity. You can read it. You can pause this video whenever you are going to learn, and you can read, because I have mentioned all the descriptions very clearly here for every meaning of what will happen in the bit 0. Because whenever you are doing a testing, or whenever someone has done a testing, whenever you are going to do the bug analysis, then might be you will get confused. So at the time, if you are reading all this, then this will be more helpful for you. DTC format. What is a DTC format? There is a lot of DTC formats. So here I have mentioned some of the DTC formats. For an example, if it is a 00 means it's called as a SAE J2012 DA DTC format, diagnostic and analysis. 01 means 14229 format. 02 is J1939 format. 303 means ISO 11992-4 DTC format. 04 means SAE J2012 DA DTC format as per J2012 WWH OBD. 05 means under the design for next generation vehicles. For an example, EV or HV, these all are the vehicles. And 06 to FF, the range is reserved for future use. So this is also you should know about it. Then only you will come to know what kind of DTC format you are using. Then based on that, you can do development or you can do the analysis. This is very commonly, as you all knows it, might be 19 service which is used to read DTC. Basically, for DEM relevant, we can use the 3 services. One is 14 service, that's for clear DTC. 19 service, that's for read DTC. You can use the 85 service, that's for controlling the DTC on and off. Here I have mentioned the 19, and under DEM playlist, DCM playlist, I'm planning to cover all the services. That time you will come to know more clarity. But here I have mentioned some subfunctions which is frequently used related with the DEM. For an example, 19 service ID you can use from 01 to 0E, And still, according to ISO documents, still there is a lot of subfunctions, but I have covered major parts. So whenever you are going to send 1902 or 1904, then DTC number, then additional with FF, then you will come to know about the snapshot record number for the particular status. So this is also, you can read it. Then whenever you are going to use, or whenever you are going for an interview, this will help you a lot. Whenever 1902, then it will read the DTC by status mass. Whenever you are going to use the 01, report the number of DTC by status mass. And whenever you are going to use the 1905, then report stored data by record number. So 90A, it's report supported DTCs. So this will help you a lot to understand more detail about the 19 service. This is one simple example I have taken. For an example, I have configured DTC with one DEM event, because DEM event, the DTC will be associated with the DEM event. I have selected the debounces monitor internal, but I am not doing anything with the aging. So first I have flashed my hex, then I am reporting a DTC. Reporting a DTC means I am actually sending an argument with event ID, and I am just saying that DTC is failed. Then I am immediately reading the DTC status byte 1904 DTC number FF. So I'm coming as a response as 2F. So 2F means, you can see now, 2F means this case. So the test file, these all are the bits will get set. As I said, these all are the possible combinations, or most of the possible combinations I have mentioned here. So here, same driving cycle, I'm reporting a DTC, I'm reading by using a 19 service, I'm coming a status bytes with 2F. You can see now 3 byte DTC number, the 4th byte is a DTC status byte, 2F. Within the same driving cycle, I'm just making the inactive of the fault, meaning I'm just passing as a passed as an argument. Then I'm reading the DTC status byte. I'm getting the result with 2E. So you can relate now, 2E means how you can really set it. So in that case, 2E means you have to see this part. You have to activate the bit. Then you will come to know whichever the bit is set, then what is the meaning of that. Okay, then within the same driving cycle, I am actually inacting the fault, reading the status byte. Then I'm ending the driving cycle. So that is, you can consider like I'm entering into the next driving cycle. Then I'm reading the status byte with the same 1904. Then I'm getting with 6C. So now why I'm doing all these things is, within the same driving cycle, what all are the status? With the next driving cycle, without doing any other activity, what is I'm getting? That's I have mentioned it here. Then now I'm reporting the DTC again, because here already I have made the inactive, right? Inactive in the sense I send as a passed. Then I'm reading all the status. So here in the 10th step, I'm reporting the DTC again. Then I'm trying to read. Then I'm coming this as a response. This is a one simple step I have mentioned, and I am planning to take separate videos for DTCs when you are selecting a debounce with monitor internal, with some aging setup, then with counter, then timer base. All these things I am planning to take as a separate video. There you will come to know about it, how exactly the DTC life cycle in the driving cycle with a particular debounce method. But this is with monitor internal, and there is no aging. Now, since we have handled everything is a UDS DTC, OBD relevant, now we mentioned about the J1939 DTCs as well, right? So what is J1939 DTC? So J1939 consists of 4 fields that relay data about the fault the DTC is reporting. That is for suspect parameter number, SPN. So this represents SPN with error, and each one can be used in a DTC. It describes the parameter by providing the data type, data length in bytes, range, resolution, reference tag or label, and offset. Next one is a failure mode identifier, FMI. This represents the type and nature of the error, such as sensor short circuits, calibration error, value range violation, either high or low, and incorrect update rate. Next one is occurrence counter. It's called as OC. This counts the number of the error conditions occurrence for every SPN. That means suspect parameter number. The OC also stores this information even when the error is already inactive. The next one is SPN. SPN conversion method. The CM describes the byte alignment in the DTC. So this is a very short information about J1939 DTC. And there are other popular DTC code list also, but it depends on your OEM and the requirement and all. So this is the basic information about the DTC overview and DTC status and what all are the DTC combinations. All these informations we discussed in this video. Hope you have a clarity about DTC overview. Whenever you have a questions, you can mention it in the chat. I will immediately answer it. Whenever you have a doubts or whenever you need a specific videos, definitely we will consider it. So thanks for your time and thanks for watching this video. If you like it, please share it with your friends. If you want to stay with us for more technical content, then please subscribe our channel. Thank you so much. Have a nice day.